Hi, welcome to DEITV. This is episode 5. I am your host, Salomon Alcocer Guajardo. In today's episode, I'll review the diversity indices. In particular, I'll review the Simpson index. I will then cover the Wilcox index. And then, consistent with the previous episodes, I will apply the Wilcox index to the gender, ethnic, and revenue data. Then I will discuss the additional resources. I'll give a quick blurb of episode 6. And in contrast to the previous episodes, I will give a schedule of the upcoming episodes. Thank you, stay tuned. As I mentioned in the previous episodes, there are probability-based indices and there's also logarithmic-based indices. The probability-based indices include the Hurlbert index, the Offset index, McIntosh index, the Simpson index, the Smith and Wilson indices, and the Wilcox index. The logarithmic-based indices include the Heap index, Hill, Hurlbert logarithmic index, Shannon, Sheldon index, and the Smith and Wilson logarithmic-based index. Again, this episode will cover the Wilcox index. In the next slide, we'll start to review the Simpson index because, again, the Simpson index is the basis for all the probability-based indices that will be covered in this channel and in subsequent episodes. Now, to review the Simpson index, there are multiple ways that the index is represented in terms of formulas. One formula is 1 minus the sum of the frequency squared divided by the total number of employees squared. So that is 1 minus sum of little n squared divided by big N squared. That is also represented as 1 minus the sum of the percentages squared. That's in the second part of the slide. So it's 1 minus the sum of p squared. Another way to represent the index is 1 minus the Simpson concentration score. And recall that the Simpson concentration score is essentially the sum of little n squared over big N squared, or it can be represented as the sum of the percentages squared. When frequencies are used, we can obtain the unbiased index of diversity, and the unbiased index of diversity is 1 minus the sum of the frequency times the frequency minus 1. Divide that by the total number of individuals times the total number of individuals minus 1. Again, that can also be just represented as 1 minus the unbiased Simpson concentration or similarity score. Now we have the biased Simpson standardized or Evenness score, and that is obtained by dividing the concentration score by the maximum Simpson diversity score. And recall from the previous episodes, the maximum Simpson diversity score is k minus 1 divided by k, and where k is the number of groups, so it's the number of groups minus 1 divided by the number of groups. That gives us the maximum value for the Simpson score. Recall that the biased Simpson index is obtained by 1 minus the sum of the frequency squared divided by the total number of individuals squared, or it can also be represented as 1 minus the sum of p squared, and p squared is the percentage. So obtain the biased Simpson Evenness or standardized scores with the percentage. You just get the Simpson dominant concentration or similarity score divided by the maximum. Another way to represent that is 1 minus the Simpson concentration score divided by the maximum score. Or a simpler way of doing it is diversity score minus the maximum score. So there are 4 ways that the Simpson Evenness score is represented on this slide. Recall from the previous episodes, I mentioned that we have the unbiased Simpson Evenness or standardized score. And here we get the unbiased Simpson diversity score divided by the maximum score. And as the slide shows, we have 3 ways of representing that. One way to represent it is 1 minus the sum of the frequency times the frequency minus 1 divided by the total number of individuals times the total number of individuals minus 1 divided by the maximum score, which is obtained by k minus 1 over k. A simpler way of representing the formula is 1 minus the unbiased Simpson concentration or similarity score divided by the maximum score. And again, that gives us the unbiased Simpson evenness or standardized score. As I mentioned at the beginning of the episode, this episode will cover the Wilcox index. Alan R. Wilcox created the index in 1967. It is based on the Simpson index. However, the rationale for Wilcox creating this index is not given in the memo that he issued. So why the formula is complex, why does it have its particular elements, is unknown, because when Wilcox proposed this index, the proofs and everything else that were supposed to accompany the memo was not provided. So all we have is just the index that he created and the formula. The value of the index ranges from 0 to 1. It is applied to qualitative based data that's reported as frequencies or percentages. In the application section, you will notice that when you use frequencies, the numbers get extremely large, so I prefer using the percentages. It is probability based, meaning that it provides the probability that two individuals chosen at random will differ with respect to the demographic characteristic in question or at hand. It provides a standardized or evenness score of diversity. As I just mentioned, the formula for obtaining the Wilcox index is complex. Again, the rationale for the formula was not provided by Wilcox in his memo of 1967. Again, you can use frequencies or you can use percentages. The structure of the formulas are similar to the structure that Simpson used, except that we're using the square root of the concentration or similarity scores. So the first way of representing the formula is provided on the right hand side, which is 1 minus the square root of the sum of n squared minus the total number of individuals in an organization squared divided by k, the number of groups. You divide that product by the number of individuals in the organization squared times k minus 1 divided by k. And that's subtracted from 1 to obtain the diversity score. Another way to represent the formula is when you use percentages, which is the easier way to calculate the diversity scores. So that's going to be 1 minus the square root of the sum of the percentages squared minus 1 over k divided by k minus 1 over k. So the maximum score that can be obtained by the Wilcox index is the total number of individuals, big N, squared, times k minus 1 divided by k, or it can be k minus 1 over k if you use percentages. The Wilcox similarity or concentration score is given by the sum of the frequency squared minus the total number of individuals squared, so that's big N squared, divided by k, or simply the sum of the percentages squared minus 1 over k. Again, these are the different elements that you need in order to obtain the Wilcox standardized or evenness score of diversity. Again, for consistency with the previous episodes, I applied the formula to the same data that was used for calculating the ethnic diversity scores of this organization. Again, the same data is used. The frequencies are squared, like in the previous episodes. Again, when you square the frequencies, that gives you the Simpson dominant score. You can also use the percentages, so when you square the percentage and you add them up, that gives you the 0.616. So when you apply the formula to the data, you get a diversity score at the far left of 0.284. That is significantly smaller than what we get for the Simpson index, the McIntosh index, and the other indices that were covered in previous episodes, as I will demonstrate in this forthcoming slide. And the reason for that is that we're taking the square root of the dominant score divided by the maximum score, and when you take the square root, that gives you a smaller product. So when you subtract that from 1, you get a smaller diversity score. As I mentioned a few seconds ago, the Wilcox index yields diversity scores that are significantly smaller than the previous indices that were discussed. So for example, if we take the Bias-Simpson evenness score or standardized score, that's 0.487. Again, if we look at the Wilcox score, that's 0.284. The unbiased Simpson index yields a diversity score, a standardized diversity score of 0.492. Again, the Wilcox index is smaller than that. Recall that the McIntosh index is also partially based on the Simpson index. Its formula is a little bit more complex, but still we get a diversity score of 0.395. Again, the Wilcox index yields a diversity score of 0.284. Again, it's because it's using the square root of the product. The Hurlbert index, both the relative index, which is represented as DH2, that yields a relative diversity score of 0.431. Again, it's larger than the Wilcox index. Even the Hurlbert standardized index is 0.393, which again is larger than the Wilcox index. So generally the Wilcox index will produce a smaller diversity score in comparison to the other indices, simply based on the way the formula that was constructed by Wilcox is applied to the data. As I said at the beginning of the episode, I'm going to apply the Wilcox index to the same gender, ethnic, and gender and ethnicity data that was used in the previous episodes. I'll also apply the index to the revenue data and the revenue scenario that I developed in the previous episodes to illustrate how the index is applied to different demographic data and revenue data. And again, I will concentrate on the evenness or standardized score because that's what the index produces. And then after the application, I'll talk about the additional resources. As I mentioned at the beginning of the episode, I'm going to apply the Wilcox index to the same gender, ethnic, and gender by ethnicity data, as well as to the revenue data. So let me go to Share. Again, this is the same data that's been used in the previous episodes. I mentioned that I can use frequency data or percentage data. Again, to repeat or to review what was covered in the previous episodes, in this organization, I have 65 males, 25 females, 5 individuals of some other gender, and 5 that are unclassified, for a total number of 100 individuals. So let me go to how to calculate the maximum score of the Wilcox index. Here's the formula. So it's going to be total number of individuals squared, so that's big N squared. So in this case, it's going to be 100 times 100. Times that by the number of groups or categories minus 1 divided by the number of groups. So that's going to be, in this case, it's going to be I4 minus 1 divided by I4. So that gives me a maximum score of 7,500. If I use the percentages, that gives me 0.75. To obtain the Wilcox dominant score or concentration score, that's going to be the total number of individuals squared that's 4,900. I'm going to subtract that from the total number of individuals squared, which is in this case G4, which is capital N squared, 100 times 100, divided by the number of groups, which is 4. So that product gives me 2400 if I'm using the frequencies, 0.240 if I'm using the percentages. To obtain the Wilcox Evenness or standardized score, remember I'm going to use the square root of the dominant score or concentration score divided by the maximum. So, and then I'm going to subtract that product from 1. So when I subtract 1 from the square root of the concentration score divided by the maximum score, that gives me 0.434, which is the probability. There's a 43% chance that the individuals selected at random will differ from each other. That also represents that 43% of the maximum value of diversity was obtained. Now for comparison, I included the Simpson index. Remember that the maximum score of the Simpson index is number of groups minus 1 divided by the number of groups. Symbolically, that is k minus 1 divided by k. In this case, there are 4 groups. So it's going to be 4 minus 1, which is 3 divided by 4. So it's 3 divided by 4 gives us 0.75. The Simpson similarity score is 0.490. When you subtract that from 1, that gives us a diversity score of 0.510. When you divide the 0.510 by the maximum score, that gives us a diversity evenness score, standardized score of 0.68. And that 0.68 indicates that 68% of the maximum value, 0.75, was obtained. As I mentioned, the Wilcox index generally produces diversity scores that are smaller because of you're subtracting the square root of the product from 1. Now let me go to apply the Wilcox index to the ethnicity data. Again, this is the same data that's been used in the previous episodes. So here, in terms of ethnicity, I have an Asian workforce composed of 5 individuals. I have a Black workforce composed of 20 individuals. A Hispanic workforce composed of 15 individuals. I have a workforce of 50 white employees, and I have 10 individuals of some other race. Again, that gives us a total of 100. When I sum the frequencies, and I square them, that's going to be 3250. In this case, what I did in previous episodes, you notice that I used the power function here. I just times the frequency times itself. So the formula on how to square the frequencies is provided on the screen. So G4 is composed of B4, which is 5 times B4, again, so it's 5 times 5 plus 20 times 20, so that's C4 times C4 plus 15 times 15, so that's D4 times D4, plus the square frequency of the white workforce, plus the square frequency of the some other race workforce, and that gives me a total of 3250. The maximum score, again, I obtained for the Wilcox index. So that's the total number of individuals squared, subtracted by k minus 1 divided by k. So in this case, it's going to be H4, which is 100 times 100. And I times that by 5 minus 1, which is 4 divided by 5. So that product gives me the maximum Wilcox score. To obtain the Wilcox concentration or similarity score for ethnicity, I'm going to take the sum of the frequency square, which is 3250. I'm going to subtract that from the total number of individuals in the organization squared. So that's 100 times 100 divided by k, which is the groups. So in this case, it's going to be J4, which is 5. So it's going to be 100 times 100 divided by 5. I'm going to subtract that from G4, which is 3250. Now to get the Wilcox evenness score, standardized score, I'm going to calculate the square root of the Wilcox similarity score, which is 1250, divide that by the maximum score, K4, which is 8,000. I'm going to take the square root and subtract that from 1. So that gives me a diversity score of 0.605. And again, that's interpreted as the organization obtained 61% of the maximum possible value of diversity. Again, for comparison, I calculated the Simpson scores against the maximum score is K minus 1 divided by K. So in this case, it's going to be 4 divided by 5. Gives me 0.80 as the maximum score. I calculated the Simpson dominant score. In this case, it's going to be the sum of n squared divided by total number of individuals squared. So when I subtract 0.321 from 1, that gives me the Simpson diversity score of 0.675. And again, if I divide that 0.675 by the maximum score of 0.80, that gives me a diversity score, a standardized Simpson score of 0.844, indicating that 84% of the maximum value of any diversity was obtained by this organization. Again, for consistency with the previous episodes, I have the workforce classified by their ethnicity and gender. Again, the Asian workforce consists of 5 individuals. Of those 5 individuals, 3 are male, 2 are female, 0 are under some other gender group, 0 under unclassified. Again, I have the total Black workforce in the organization, which is composed of 20 individuals. Those 20 individuals are then classified by their gender. So I have 13 male, 4 female, 2 some other gender, 1 unclassified. I have the same for the Hispanic workforce, classified by their ethnicity, classified by their gender. The same for the white work group, the same for the other race work group. Again, I sum the frequencies, I square the frequencies and sum the product. In previous episodes, again, I used the power function, but because they have 20 groups, it's easier for me to put the frequency times the frequency. So in this case, for example, I have B4 times B4, which is the number of Asians that are male, plus C4 times C4, which is the number of Asians that are female, and so forth. So when I sum the frequency squared, this gives me 1684. Again, I calculated the maximum score for the Wilcox index. Again, I have 100 individuals in the organization. So it's going to be 100 times 100, n squared. I have the number of groups, which is 20. So it's 20 minus 1 divided by 20. Again, the formula is k minus 1 of k. That gives me 9,500. To calculate the Wilcox similarity concentration score, I get the frequency squared, which is 1684. I subtract that from the total number of individuals squared. So it's AB4, which is going to be 100 times 100. Divide that by the number of groups, which is 20. So that gives me 1184. So 1184 divided by 95. I'm going to take the square root of that product, subtract that from 1. So it's 1 minus the square root of 1184 divided by 9500. That gives me a Wilcox standardized or evenness score of 0.647, which indicates that 65% of the maximum possible value of diversity was obtained for ethnicity and gender combined. Again, for comparison, I calculated the Simpson index. So again, it's going to be, to obtain the maximum, it's going to be 20 minus 1 divided by 20. So it's going to be 19 divided by 20, gives me a 0.95. Here, what I did, remember, there are multiple ways to calculate the Simpson dominant score or concentration score. What I did here, and remember, I have the frequency squared, so it's the frequency squared minus the total number of individuals squared. So the formula has AA4, which is 1684 divided by 100 times 100, big N squared. So that gives me 0.168. I subtract that from 1. So that gives me a diversity score of 0.832. So when I divide 832 by 95, that gives me a standardized score of 0.875, which indicates that 88% of the maximum value of diversity was obtained. So for consistency with the previous episodes, let me apply the Wilcox index to the contingency table. Again, recall that I first analyzed the data for gender, so I'm going to go through all the male by ethnicity. So again, to square the frequencies as the formula requires, I can do it one or two ways. I can use the power function, or I can just go through each cell and times the frequency by itself. So here what I did, so for the number of males that are Asian, the formula is parentheses B4 times B4, so it's 3 times 3, plus parentheses 13 times 13, so that's C4 times C4 for the black males workforce, plus the frequency times itself for the Hispanic male workforce, all the way to some other race. So when I sum the squared products of the frequencies for the males, that gives me 1450. Then there's a total of 65 males in this organization. The number of groups is K. So to calculate the maximum Wilcox score is going to be the total workforce, so in this case 65 times 65, so that's N squared. So for H4, it's going to be 65 times 65 times the number of groups minus 1 divided by the number of groups. So it's going to be 5 minus 1 divided by 5. So when I times the N squared times K minus 1 divided by K, that gives me a 3380 for the males. To obtain the Wilcox dominant score or similarity concentration score, is going to be N squared, little n squared. So it's going to be the frequency squared. So that's 1459 minus the total number of individuals in the workforce. So that's 65 times 65 divided by K. In this case, it's going to be 5. So that product gives me 614. So to obtain the Wilcox evenness or standardized score, is going to be 1 minus the square root of the diversity concentration score divided by the maximum score. So it's going to be the square root of 614 divided by 3380. Subtract that from 1. That gives me 0.574. So for the male groups, that means that the organization obtained 57% of the possible maximum value of male by ethnicity. And again, if I just want, I can drag that formula down, and that gives me, oops, excuse me, hit undo. So let me just go from K4. So if I drag that down, that's going to give me the diversity scores for the other groups. K stays constant because there's 5 groups. So for the total organization, the diversity score is 0.605. And again, just for comparison, I included the Simpson indices. I'm not going to go through that again. And again, for the total organization, the organization obtained 61% of the maximum possible value of gender by ethnicity. Again, if I look at it, if I go by each individual ethnic group and obtain the diversity for each ethnic group and gender, so there are four groups for gender. So K is 4. So for the Asian group, if I want to obtain the maximum score, it's going to be 5 times 5, so it's B8 times B8 times B14, which is 4 minus 1 divided by B14. So that gives me 1875 for the maximum score. The Wilcox similarity or concentration score equals B13, which is going to be the sum of the n squared. So that's going to be 3 times 3 plus 2 times 2. That gives me n, little small n squared, so that's 13. Subtract that by the total workforce, which is 5, so it's 5 times 5 divided by B14, which is the number of groups, K. So that gives me the similarity score. So to obtain the diversity score, I'm going to take the square root of B16, which is the Simpson concentration score 675, divide that by B15, which is the maximum score of 1875. I take that square root of that product, subtract that from 1, that gives me 0.40. So for the Asian workforce, the organization obtained 40% of the maximum value of 18.75 for gender. Again, if I just want to, just can copy that formula over for the other groups. And that gives me the diversity score for the other groups. Again, I can copy that same formula for the total population, for the total workforce. And that gives me 0.434 as a diversity score, standardized score, Wilcox score for the entire organization for gender. Again, for comparison, I calculated the Simpson scores. Again, I can do that by cell, so I can get the level of ethnicity and gender combined. Again, there's 20 cells, so there are 20 groups, 20 categories. Again, if I'm going to obtain the maximum value, that's going to be H9, which is 100, so 100 individuals in the organization, so it's 100 times 100, times K minus 1 over K, so it's going to be 20 minus 1 divided by 20. So that gives me a maximum value of 9,500. Then to obtain the Wilcox dominant score, the concentration score, is going to be little n squared, so that's the frequency, that's 1684. I'm going to subtract big N squared, so that's going to be H9, 100 times 100, divided by the number of categories, number of groups, which is H26, which is 20. So that gives me 1184. So to obtain the diversity, the standardized Wilcox score, I'm going to take H28, which is 1184, which is the Wilcox concentration similarity score, divide that by the maximum score, 9500. I get the square root of that, subtract that from 1, and that gives me a standardized Wilcox score of 0.647, which means that the organization obtained 64% with a maximum score of gender by ethnicity. Again, that Wilcox score is smaller than the Simpson score, again, because you're subtracting 1 from the square root of a product. So that's how you apply the Wilcox score to the contingency table for ethnicity by race, ethnicity by gender. So now let me move on and go to apply the Wilcox formula or index to the revenue data that's been analyzed in the previous episodes. So here I have the revenue data for this corporation. Recall that I mentioned at the beginning of the episode, or towards the beginning of the episode, that using the frequencies of the data yields large sums for the products. So I prefer using the percentages. But here again, I have $80,000 in corporate donations. I have $250,000 for individual donations, $45,000 for fundraising. Revenue investments yielded $10,000 in revenue. We had $18,000 in revenue, for a total amount of revenue is $403. So I've summarized, so I got each individual revenue item and squared the value. So to obtain the sum of the frequency squared, it's going to be 80,000 times 80,000. So again, it's B4 times B4 plus 250,000 times 250,000. That's individual revenue. So that's C4 times C4 plus D4 times D4, which is 45,000 squared, plus the amount of investment revenue squared. So that's 10,000 times 10,000. So it's E4 times E4 plus the revenue generated by grants squared. So that's 18,000 times 18,000. So that gives me this large number. So to obtain the maximum value, it's going to be total revenue, big R squared, or N squared, big N squared. So that's 403,000 times 403,000 times the number of categories minus 1 divided by the number of categories. So it's 4 divided by 5. That gives me this astronomical number for the maximum value. To get the Wilcox concentration or similarity score, I get the small n squared or small r squared minus the total revenue squared divided by the number of categories. So in this case, it's going to be G4 minus H4 squared, so it's 403,000 times 403,000. I get that product and divide that by 5, which is the number of categories, K. So that gives me the Wilcox similarity concentration score. So to obtain the Wilcox standardized or evenness score, I'm going to subtract the Wilcox the Wilcox similarity concentration score, which is L4, divided by the maximum score, which is K4. Take the square root of that product, subtract that from 1, and that gives me a diversity score of 0.453, indicating that 45% of the maximum value of diversity of revenue was obtained. Again, I can do revenue scenarios. So here I increased the corporate revenue from 80,000 to 95,000. I left the individual donations static or constant. I increased the fundraising revenue to 65,000 from 45,000. Investment revenue I increased to 25,000 from 10,000. Grant revenue I increased to 30,000 from 18,000. Gives me a projected revenue of 465,000 total. Again, if I square each revenue item, that's going to give me this astronomical number again. So what I did, to make it simple, I just copied the formulas from the top to the rows with the revenue simulation. Again, the formula, the methodology and the formula stays the same. So it's going to be total revenue. So in this case, it's going to be the projected revenue of 465,000 times 465,000. So H9 times H9 times the number of categories minus 1 divided by the number of categories. So it's 5 minus 1 divided by 5. And that gives me the maximum value. To obtain the Wilcox concentration score, again, I'm going to get the sum of each revenue item squared. So it's little r squared or little n squared. I'm going to subtract that from total revenue squared divided by the number of categories. So that's going to be 465,000 times 465,000. That product is divided by 5. And again, subtract that from the sum of little r squared. Then what I do is to obtain the Wilcox standardized or evenness score for the revenue scenario, I get the Wilcox similarity of concentration score divided by the maximum score. This case is going to be L9 divided by K9. I'm going to get the square root of that product, subtract that from 1. That gives me a diversity score of 0.556, indicating that if I obtain the revenue projection, the new revenue increases will generate a diversity score of 0.56, indicating that 56% of the total amount of revenue diversity will be obtained. The other thing I want to show you is I have these percentage increases. And the reason why I have it here is that it suggests that the Wilcox index seems to be more robust in detecting differences and increases in revenue. The shift in the Simpson index is only 15%. So the data suggests that the Wilcox revenue has more discriminatory power in detecting subtle differences and increases in diversity in comparison to the Simpson index, despite the Wilcox index generating smaller diversity scores. I just wanted to show how to assess the discriminatory power of revenue indices or indices, diversity indices in general. And one way of doing that is to just get the percent increases or the percent growth in the diversity scores, and that gives you some indication of how robust an index is. The Wilcox Index is covered extensively in several books. One book that you can purchase from Amazon or from the publisher, Cambridge Scholars Publishing in the UK, is Assessing Organizational Diversity with the Smith and Wilson Indices. That covers the Wilcox Index. In addition to covering the Wilcox Index, 5 different regression models are applied to the index to assess how the index functions based on different statistical analyses. The Wilcox Index is also assessed and assessing the validity of diversity indices. Again, the book is available through Amazon and also through the publisher, Cambridge Scholars Publishing in the UK. In assessing the validity of diversity indices, the Wilcox index is compared to the Simpson index, the McIntosh index, and other indices based on the Simpson index. The third resource that you can purchase through Amazon or through the publisher is assessing organizational diversity with quantile regression. And again, quantile regression is applied to the Wilcox index at 4 different levels: at the 25th percentile, the 50th percentile, the 75th percentile, and the 90th percentile. And that is to see how the index functions based on different statistical analyses. So these are 3 additional resources that you can purchase and that you can use as a reference to obtain a more thorough understanding of the Wilcox index. To end today's episode, let me mention the upcoming episode 6, which will cover the COFSET index. So in episode 6, I will cover the COFSET diversity index, the COFSET homogeneity index, and also the COFSET evenness index. And then consistent throughout the episodes, K represents the number of categories or groups, P represents the percentage of individuals in each category or group. Although the COFSET index does not use the total number of individuals, when I refer to the total number of individuals, that is capital N, frequency is a small n. And to be consistent with the previous 5 episodes, I will apply the COFSET index to the gender data, ethnic data, the gender by ethnicity data, as well as the revenue data. So stay tuned for episode 6, which will be published or released within a week. Thank you. See you soon.